Hi, we continue our lecture on partial fractions, and we're going to be moving to another part of it, which is solving questions with repeated linear factors. Now, looking at the question that we have before us, we can see that we have a denominator that is not in the expression where we can have that is factorizable. Let me use that simple English. So, the way that we express questions that come in this form is such that we put it in this form: a over x minus 2 plus b over x minus 2 squared. Now, when you have a question where you just have one figure that is raised to a particular power, you simply just repeat it in ascending order until you get to the power that is indicated in the question. Now, if the power indicated here is say 4, that means that we're going to have plus cx minus 2 into bracket 3, then we have plus d x minus 2 into 4. So until you get to the highest power indicated in the question, you will not stop. So in this case, because we have 2, we are stopping, but it must be the same figure that you have. For in this case, because it is 2, we can only repeat it twice. Probably in subsequent examples, we are going to see when we have for higher powers or some other ways that this question can have an expression. Now, so let us solve this now. And so that means that we are going to equate this and this to be equal to this. So we simply say 2x plus 3 over x minus 2 squared equals to, is equivalent to x minus 2 plus b into x minus 2 squared. So like we usually do, we'll solve for the right hand side, my right hand side. So this we find the LCM. So we definitely know that x minus 2 squared is going to be the LCM of this particular expression. So we have x minus 2 all squared. And so if we take it now, this is just going to be a into x minus 2. If we divide the expressions, then if we divide this, b is just going to stand alone. So this is what we are going to have. Like I said, now we are going to be dealing with just the numerator, 2x plus 3 over x minus 2. Since the numerator is what we need, we just take them together. So we say 2x plus 3 equals to a into x minus 2 plus b. Now, there are two ways that we can obtain the value of a and b in this expression. I'm going to be showing you one of the ways, or if there's time, I'll show you the two ways to obtain the value for a and b. Now, the first way is what we have been looking at from the start, and that way is that we simply we try to eliminate one of the expressions. So in this case, if I'm going to eliminate a, since this is the only one that carries an expression, so I simply need to introduce, let's say x is equal to 2, a positive 2. So if I say let x be equals to 2, in this case now we have 2 into 2 here, right? Plus 3 equals to a into 2 minus 2 plus b. You see that now? So then this is out. So we have 2 times 2, 4, 4 plus 3, that's 7. So we have 7. So the value of b, so b equals to 7 in this case now. Now to get a, what do we do to get a now? Since we have this expression, we have a value for b now. Now we are going to be comparing. Now let's try to expand this expression, a into x minus b. Now let's expand it. Let's expand this particular expression. Let me write it out again. 2x plus 3 is equals to a into x minus 2 plus b. So if I expand this now, this will become 2x plus 3 equals to ax minus 2a plus b. Now, what we do with this line is that we compare. Now, it simply means that if you look at this, look at both sides now, let's make them equivalent. That's what's going to help us. They are equivalent to one another. Now, these three indicates equivalence. If it is 2, it means equal. Now, 2x and ax, I can say they are the same thing. Then these 3 and these other expressions, I can group them together. It's a very valid proposition that I can take into consideration. Since we already have a value for b, I will leave that. Then I will just take these 2x and ax. So I'll say by comparison, 2x equals to ax. And I can see that x is common for both sides, so I will eliminate the x. I get me now. Then I say what? A equals to 2. You see how simple that is? So that's the way you can approach it. Now, let's put in the values for a and b into this expression again now. So we have 2x plus 3 over x minus 2 all squared is equal to 2 over x minus 2 plus b is what? 7 over x minus 2 all squared. So this is the value of our expression. What make this equivalent? So this expression is equivalent to this. You can also perform your check, like I've always taught you. You can run your check to see what you have done is very correct. So don't be shy. Follow the principles that I've taught you here for how to obtain the unknown for this. Take note that this expression will repeat till you get the higher powers. That's the most vital thing about the repeated linear expression. I'm going to do another example under the repeated linear factor in the next video. So I want you to watch it. Thank you. Remember to share, like, subscribe, share with your classmates. These are very important videos that will help to boost your knowledge and make you to be the best in your class, help you to reinforce the things that you are learning. I hope to hear from you. I hope for positive reviews. Thank you so much.